Hi students, in this video we are going to solve a problem from the chapter limits and derivatives. So the question is, let f from R to R be a function such that f of 2 equals 4 and f dash of 2 equals 1. So what was given is a function from the real number system R to the real number system R, which means the function is a real valued function. Okay, so and f of 2 equals 4, which means the value of the function f at 2 is 4, and f dash means the derivative of the function f, so its value at 2 is 1. So these are all the given things. And then the value of limit x tends to 2 x square f of 2 minus 4 times f of x over x minus 2 is dash. So we have to find the value of this limit. Okay, so let us first write the given things. F of 2 equals 4, f dash of 2 equals 1. So the given thing is limit x tends to 2 x square f of 2 minus 4 times f of x over x minus 2. So we have to find the value. So whenever we have given the limiting process, first we have to substitute the limiting number, which means we have to substitute 2 in place of x. Okay, so replacing 2 in this equation, we get 2 times 2, which means 2 square f of 2 minus 4 times f of 2 over 2 minus 2. Okay, so which equals 2 square is 4, and f of 2, the value of f of 2 is 4. So 4 times 4 minus 4 times f of 2, the value of f of 2 is again 4 over 2 minus 2 becomes 0. In the numerator we have 4 times 4 16 minus 16 over 0, which becomes 0 by 0. So we get 0 by 0. This value is called indeterminate form. This value is in the form of indeterminate form. So there are more indeterminate forms like this, like infinity by infinity, and infinity power 0, and 1 power infinity, and infinity minus infinity. These are all some indeterminate forms, and 0 into infinity. So these are all some indeterminate forms. So what we should do now, this is not a correct value, or this is not even a value, right? This is of a indeterminate form. So we have to find the value of this given limit. Okay, so whenever we are end up like this, we have a solution to this. Okay, which means using L'Hopital rule. L'Hopital rule. This rule states that if limit x tends to a may be any number. Okay, f of x over g of x, we have a rational functions f of x by g of x equals, if this f of x over g of x becomes any of these indeterminate forms, then limit x tends to a f dash of x over g dash of x. So the value of this limit is same as the value of this limit. So we have to differentiate both the numerator and the denominator separately. So here we have x square f of 2 minus 4 times f of x over x minus 2. So we have to differentiate both the numerator and the denominator separately. So this is the rules given by L'Hopital. Okay, so let's start. limit x tends to 2, x square f of 2 minus 4 times f of x over x minus 2 equals, we have to differentiate both numerator and denominator separately. So limit x tends to 2. So what we have here, x square times f of 2. F of 2 is nothing but is just a value, right? F of 2 is 4. So it's just a constant. So we have kept f of 2 as it is. And then what we are left with, x square. So we have to differentiate x square. So you guys know the differentiation rules are, if we differentiate x power n, d by dx of x power n, we get n times x power n minus 1. This is the rule, right? So applying this rule here, we get 2 times x power 1, right? And then minus 4 f of x. So we have to differentiate f of x, right? So this means f dash of x. There are more notation for these things like y dash and more notations are there. We use just f dash of x. Fine. Over x minus 2, we have to differentiate x minus 2 separately. So differentiating x, which gives 1, minus differentiating a constant becomes 0. So we have limit x tends to 2, we have 2x power 1 into f of x, right? So 2x into f of 2 minus 4 times f dash of x over 1 minus 0 becomes 1. So now we give the limiting process, okay? So substituting 2 in the place of x, we get 2 times x, then 2 times 2, f of 2. So what's the value of f of 2? We just replace that. F of 2 is 4, okay? So we get 4 here minus 4 times f dash of x. So f dash of, in the place of x, we just 2, we just put 2 over 1. So denominator becomes 1, we don't need to write that, okay? So next 2 times 2 is 4, and we have another 4 here, we just write here, and then minus 4 times f dash of 2. The value of f dash of 2 is given as 1, okay? So we just replace 1 equals 4 times 4 is 16 minus 4 times 1 is 4, which means 16 minus 12, sorry, 16 minus 4 is just 12. So the value of the limiting function is 12. That's it.